This tutorial is about acid-base neutralization reactions, a special type of double displacement reactions involving an acid reacting with a base. So as mentioned, acid-base neutralization reactions are a special type of double displacement reactions. So if you recall, double displacement reactions involve two compounds reacting. The cations and anions of both compounds split up and rearrange themselves to form two new compounds. But what's unique about acid-base reactions, first of all, is that the two reactants are an acid and a base, but secondly, that the two products are always essentially the same. So one of the products is always water, and the second product is called an ionic salt. Now when you hear salt, you probably think of table salt, which is sodium chloride. And I'll show you a few examples here, but the salt that's formed in acid-base reactions is just an ionic compound, and we call that a salt in chemistry. This is the general formula for an acid-base neutralization reaction. So we have our acid reacting with our base and producing this salt or ionic compound, and water is always the other product. So you need to think about what you know about the chemical formulas of acids and bases. Acids, you know, always have the hydrogen ion, and that hydrogen ion will be with an anion. That anion, that negative ion, could be just an element like chloride or fluoride or sulfide, or it could be a polyatomic ion like sulfate, nitrate, nitrite, chlorate. So any negative ion with the hydrogen ion is an acid. In our base, we'll have a metal or the positive polyatomic ion ammonium, and then the anion, the negative part, is usually hydroxide, so OH. Sometimes we see the carbonate ion or the bicarbonate ion as well, and those are some common bases in terms of their negative anion. But usually it's the hydroxide. So if you think about it, what do you get if you put H with OH? And you guys know that that is water. That's our HOH, or water. So this is where the water is coming from in the reaction. It's the hydrogen ion of the acid reacting with the hydroxide of the base, producing water. Now, if it's a carbonate or a bicarbonate base, we will also get carbon dioxide gas as a product, because the carbon and some of the oxygen from the carbonate and bicarbonate need to go somewhere, and they produce carbon dioxide. The salt will be made up of those two parts from the acid and the base that I haven't drawn in. So they will be made up of the positive ion from the base and the negative ion from the acid. You put those together and you have your ionic salt. So here's an example of an acid-base neutralization reaction between sulfuric acid and potassium hydroxide. Here's the balanced chemical equation. So in this graphic, they have shown you the potassium reacting with the sulfate ion, and that's producing our potassium sulfate here. This is our salt, or ionic salt. And then we have the hydrogen right here reacting with the OH in the base, and if we put those two together, we form our water. And it helps if you think of water as being HOH. And certainly for balancing these, I really recommend that you look at water as being HOH, much easier to balance. Here's a neutralization reaction with a base that has a carbonate or bicarbonate in it. So in my title here I have involving carbonate bases, but it could also be bicarbonates. So we have acetic acid, which is just vinegar, reacting with sodium bicarbonate, which is baking soda, and you're all familiar with the classic vinegar and baking soda reaction. So this is what's going on here. So I'm just going to change my pen color. This is our acetate ion right here that makes up the acetic acid, and here's our bicarbonate ion right here. So the sodium from our base reacts with the acetate from our acid, and we get our sodium acetate as a product. But we're left with, we have our hydrogen here and we have our bicarbonate ion, and they are going to react, but they don't the product that they form is very, very unstable. It lasts for just a moment in time before it breaks down, it decomposes, and we get the carbon dioxide and water. So remember, water is always a product in all neutralization reactions, but in these carbonate and bicarbonate reactions, we also get this carbon dioxide right here, and these are bubbles of gas that are produced. If you think about that vinegar and baking soda reaction, kids will use it to create that volcano project or that volcano effect, and that's what's doing it, is the carbon dioxide gas. Okay, so this is a gas right here. So now I want you to try a few of these. As you know, the big skill that we've been working towards is being able to write balanced chemical reactions or equations for any type of reaction, and also to classify the type. So you do need to be able to recognize these as being acids with bases, and so it's a neutralization reaction, and that's going to help you figure out the products. Kind of the ultimate skill is to be able to predict the products based on the type of reaction, and then write the balanced chemical equation. So I've given you 3 here. 2 of them are hydroxide bases and 1 is a carbonate. So think about what you've learned in this tutorial and predict the products and then balance the equations. So I want you to pause the video, try these 3, and then turn it back on and check your answers. So here's the answers. Let's see how you did. So in the first one, the potassium, hold on a second. The potassium is going to react with the chlorine to give you your KCl. And then we have our hydrogen from the acid reacting with our OH from the base to give us our water. So that's a nice easy one, and it was already balanced. The next one, we have our magnesium metal reacts with the sulfate from the acid, and that gives us our MgSO4. They both have a charge of 2, so those two 2's cancel out and we get MgSO4. And then that leaves us with our hydrogen and our OH from our acid and base, but because we have 2 hydrogens and 2 hydroxides, I know that that's going to give me 2 waters over here. So you can actually balance this as you're writing it, because you know you're going to have, because you have 2 hydroxides and 2 hydrogen ions, you have to have 2 waters on your product side. Now the bottom one, we have this carbonate ion. So as soon as I see that, I know that carbon dioxide is going to be a product as well as the salt in the water. Okay, so we've got our calcium reacting with our fluoride ion, and that gives me CaF2. I'm crisscrossing a 2 from the calcium down, so I get CaF2. So I know I'm going to have to do some balancing here. I've got my carbon dioxide as a product that comes from the carbonate ion, and remember, water is always the other product. And so just balancing it off, I see that I have 2 fluorines over on the product side, so that's why I needed the 2 in front of HF. That takes care of my 2 hydrogens in the waters, and my carbon dioxide and my OH is balanced as well. So there you go. That's how you do acid-base reactions. You have to remember that you're always going to produce water. Your other product will be an ionic compound made from the metal of the base reacting with the anion of the acid. And if you have a carbonate or bicarbonate base, that you need to include carbon dioxide in your product. And that's it for these types of reactions.